The ocean rests quietly across the surface of the Earth, extending beyond coastlines and horizons with a steady presence. Its surface often appears smooth and unchanging, reflecting pale light from the sky above. Beneath that calm exterior, the ocean is gently alive with motion that never truly stops. Water moves in slow, deliberate paths shaped by wind, temperature, salinity, and the gradual turning of the planet. These movements are known as ocean currents, and they form the unseen framework that supports marine life across the globe. Ocean currents move with steady intention, following broad paths shaped by natural forces rather than sudden change. They drift, curve, sink, and rise with measured consistency, linking distant regions through patient circulation. Warm water travels toward cooler places, while colder water settles into deeper layers and begins long journeys across the seafloor. This constant exchange helps regulate the planet's climate and maintain stable conditions within the sea. Over long periods of time, these flows guide nutrients, oxygen, and microscopic life to where they are needed most. Marine organisms have adapted to this slow-moving environment. Many creatures rely on predictable water movement to deliver food or to carry their young to safer waters. Floating plankton drifts with ease, forming the quiet foundation of ocean ecosystems. Fish, mammals, and invertebrates align their migrations with steady currents, conserving energy while traveling vast distances. Even stationary life, such as coral and seagrass, depends on passing water to bring nourishment and remove waste. The connection between currents and marine life is subtle and enduring. Nothing moves quickly, and nothing stands apart. Each motion supports another in a balanced exchange that unfolds over years and centuries. By observing these gentle processes, a clearer understanding emerges of an ocean shaped by continuity rather than force. Within its slow circulation, the sea offers a lesson in patience, balance, and quiet interdependence. Across the upper layers of the ocean, surface currents trace wide, flowing patterns that respond gently to the movement of air above. Persistent winds glide across the sea, transferring energy through friction and guiding water along gradual routes. Over time, these motions organize themselves into broad streams that can extend for thousands of kilometers. Though invisible from shore, their presence shapes coastlines, climates, and living conditions throughout the marine environment. Surface currents are most active within the sunlit layer of the ocean, where warmth and light encourage biological growth. As water travels, it carries heat from equatorial regions toward cooler latitudes, softening temperature differences between distant places. In return, cooler waters drift back toward warmer zones, maintaining balance through continuous exchange. This circulation unfolds slowly, allowing the ocean to absorb and release heat without abrupt change. Marine life responds quietly to these steady flows. Floating organisms remain suspended within moving water, forming drifting communities that support fish, seabirds, and larger predators. Many species time their movements to coincide with seasonal shifts in surface currents, using familiar routes that reduce physical effort. Larvae released into the water depend on these gentle pathways to reach suitable habitats, where they can settle and grow. Even coastal environments feel the influence of surface currents. Nutrient-rich water may arrive from afar, supporting plankton blooms that feed entire food chains. In other regions, warm currents help maintain stable conditions for coral reefs and shallow ecosystems. Nothing occurs suddenly. Each change develops gradually, shaped by the quiet persistence of wind and water working together. Through observation, surface currents reveal how motion can remain calm while still exerting lasting influence. Their presence is felt not through force, but through consistency, guiding life and energy across the ocean's surface in a slow, dependable rhythm that continues without pause. Far below the ocean's surface, beyond the reach of sunlight, deeper currents move through darker waters with quiet consistency. These deep currents are guided less by wind and more by differences in temperature and salinity. Colder water becomes denser, especially when it contains higher levels of salt, and gradually sinks toward the ocean floor. Once it settles into deeper layers, it begins a slow, steady journey that may continue for centuries before returning closer to the surface. This process creates what is often called the deep circulation of the ocean, a global pattern that links polar seas with distant tropical regions. In colder areas near the poles, surface water cools, grows heavier, and gently descends. From there, it spreads outward along the seafloor, moving at a pace measured in kilometers per year rather than days. Over time, this deep water carries oxygen and dissolved nutrients to places far removed from their original source. Marine life in the deep ocean has adapted to these unhurried movements. Many organisms rely on the gradual delivery of oxygen-rich water to sustain their slow metabolisms. Nutrients that sink from the surface are redistributed by deep currents, supporting communities of invertebrates, fish, and microorganisms that live in near darkness. Though these creatures may never encounter sunlight, they remain connected to surface ecosystems through the shared movement of water. Eventually, deep currents rise again through a process known as upwelling, bringing long-stored nutrients back toward brighter layers. This return does not happen quickly or evenly. It unfolds over long periods, maintaining balance rather than creating sudden abundance. The deep circulation of the ocean reflects a system built on patience, where water moves with purpose yet without urgency. By observing these deeper pathways, the ocean reveals how unseen motion can sustain life across vast distances. Even in darkness, steady movement supports continuity, allowing marine ecosystems to remain connected through time and depth. As ocean water travels across wide distances, its direction is gently influenced by the steady rotation of the Earth. This influence does not push or pull the water directly, but subtly alters its path over time. In the open ocean, this effect encourages moving water to curve rather than flow in straight lines. Gradually, large circular patterns form, known as ocean gyres, occupying vast regions of the sea. Gyres develop slowly, shaped by prevailing winds, continental boundaries, and the turning motion of the planet. In each major ocean basin, surface currents trace broad loops that rotate with quiet regularity. These systems remain stable for long periods, sometimes lasting for centuries with only minor adjustments. Within their boundaries, water circulates calmly, redistributing heat and dissolved materials without abrupt change. Marine life adapts closely to these rotating environments. Plankton communities drift within gyres, forming stable feeding grounds for fish and larger animals. Some species remain within these circulating systems for most of their lives, encountering familiar conditions that change only gradually. Floating organisms, including seaweeds and small invertebrates, gather in certain regions of gyres where water movement slows, creating zones of quiet accumulation. The centers of gyres are often marked by clear, nutrient-poor water. Here, the steady rotation limits vertical mixing, resulting in calm, open seas with fewer visible signs of life. Along the edges, however, currents interact with surrounding waters, allowing nutrients to enter and support more active ecosystems. These boundaries provide gentle transitions rather than sharp divisions, encouraging gradual shifts in biological activity. Through gyres, the ocean demonstrates how large-scale motion can remain balanced and predictable. Water follows curved paths not through force, but through persistent influence applied over time. In these wide, rotating systems, the sea maintains order and continuity, offering marine life a stable framework shaped by steady movement and patient alignment with the planet itself. Along certain coastlines and open ocean regions, water from the depths slowly rises toward the surface in a process known as upwelling. This movement occurs when surface water is gently guided away, often by consistent winds or the shape of the land beneath the sea. As the upper layer shifts, deeper water takes its place, carrying with it dissolved nutrients that have accumulated over long periods. The ascent is gradual, unfolding without disturbance, yet its influence on marine life is profound. Upwelled water is typically cooler and richer in minerals than the surrounding surface layers. When it reaches sunlit areas, it supports the growth of microscopic plants called phytoplankton. These tiny organisms use sunlight and nutrients to grow steadily, forming the base of productive marine ecosystems. From this foundation, energy passes quietly through the food web, sustaining fish, seabirds, and marine mammals over time. Many of the world's most biologically active regions are shaped by regular upwelling. Coastal zones influenced by this process often support fisheries that have remained reliable for generations. Life gathers not because of sudden abundance, but because conditions remain consistently favorable. Species adapt their life cycles to these predictable patterns, reproducing and feeding in rhythm with the slow return of deep water. Upwelling also plays a role in balancing ocean chemistry. As deep water rises, it releases stored gases and absorbs warmth, helping regulate temperature and nutrient distribution across wider areas. This exchange supports stability rather than excess, ensuring that growth remains measured and sustainable. The presence of upwelling illustrates how vertical movement can be as important as horizontal flow. Without urgency or force, water travels upward, linking the deep ocean with the surface world. In this steady exchange, marine life finds nourishment and continuity, shaped by a process that values patience and quiet renewal over speed or intensity. Within the moving waters of the ocean, countless microscopic organisms drift in quiet abundance. These organisms, known collectively as plankton, include plant-like forms that use sunlight and animal-like forms that feed upon them. Plankton does not swim against the current or choose a destination. Instead, it remains gently suspended, traveling wherever the water carries it. Through this passive movement, plankton becomes closely linked to the pathways traced by ocean currents. Surface currents guide plankton across large areas, distributing life through open seas and toward coastal regions. As plankton travels, it absorbs light and nutrients, growing slowly and steadily. This growth supports nearly all marine food systems, as plankton serves as the primary source of energy for many forms of ocean life. Small fish feed upon it, larger fish feed upon those fish, and the chain continues upward in calm progression. Seasonal changes in current patterns influence where plankton becomes most concentrated. In regions where water rises from depth or mixes gently, plankton communities often flourish. These areas may appear unchanged from above, yet beneath the surface, life gathers in soft clouds of movement. The presence of plankton attracts other organisms, creating zones of quiet activity shaped by consistent water flow. Even after plankton completes its life cycle, it remains part of the ocean's circulation. As it sinks, it carries organic material toward deeper layers, contributing to long-term nutrient storage. Deep currents later redistribute these materials, continuing the slow exchange between surface and depth. Nothing is wasted or rushed. Each stage unfolds within the broader rhythm of ocean movement. By observing plankton within the context of currents, a simple truth becomes clear. Life in the ocean often depends not on strength or speed, but on the ability to remain present within steady motion. Carried gently across the sea, plankton illustrates how small, drifting forms can support vast ecosystems through patience, persistence, and quiet continuity. Many marine animals travel long distances during their lives, and ocean currents quietly shape these journeys. Rather than moving through still water, migrating creatures often align themselves with steady flows that assist their movement. By following familiar pathways of circulating water, animals conserve energy and maintain a gentle pace suited to long travel. These routes are not rigid lines, but broad corridors formed by consistent motion over time. Fish, sea turtles, and marine mammals often time their migrations to coincide with seasonal current patterns. As water temperatures shift gradually, currents guide warmer or cooler conditions across the ocean. Animals respond by adjusting their positions, remaining within environments that support feeding, growth, and reproduction. This process unfolds without haste, allowing migration to become a regular and reliable part of ocean life. Young animals are especially connected to current-driven movement. Eggs and larvae released into the water are carried across wide areas, reaching habitats far from where they began. This dispersal increases the chance of survival by spreading life across varied environments. Although the journey is passive, the outcome is shaped by generations of adaptation to predictable water movement. Even large, powerful swimmers benefit from currents. Whales traveling between feeding and breeding grounds often follow routes where flowing water supports their direction of travel. These paths reduce resistance and create calmer conditions, turning migration into a steady passage rather than a demanding effort. Over time, these routes become ingrained within species behavior, passed down through quiet repetition. Currents also help maintain connections between distant ecosystems. A reef, a coastal shelf, and an open ocean region may be linked by the same moving water, allowing life to circulate between them. This connection supports genetic diversity and long-term stability across the marine environment. Through migration, marine animals demonstrate how movement can be cooperative rather than forceful. By traveling with the ocean instead of against it, life adapts to a world in motion. In these calm, guided journeys, currents serve as steady companions, shaping pathways that continue across generations with patience and balance. Where land meets the sea, coastal currents create environments shaped by gentle exchange. These currents move along shorelines, guided by the contours of the coast, the slope of the seabed, and the steady influence of tides. Unlike the broad flows of the open ocean, coastal currents tend to be slower and more variable, adjusting gradually to changes in wind, freshwater input, and seasonal conditions. Their movement supports some of the most diverse and productive marine habitats on the planet. In bays, estuaries, and shallow coastal waters, currents mix ocean water with freshwater from rivers and rainfall. This blending creates environments with shifting salinity and temperature, encouraging a wide range of organisms to settle and grow. Nutrients carried from land are distributed by these currents, supporting plankton growth that forms the base of local food systems. Over time, this steady circulation sustains fish nurseries, shellfish beds, and rich plant life. Many marine species depend on coastal currents during early stages of life. Larvae and juvenile animals remain sheltered in nearshore waters, where gentle movement brings food while limiting exposure to open ocean conditions. Seagrass meadows and kelp forests thrive in these zones, their flexible forms moving slowly with passing water. Currents deliver dissolved gases and nutrients while carrying away excess material, maintaining balance without disruption. Tidal currents add another layer of rhythm to coastal environments. As tides rise and fall, water moves in predictable cycles, renewing oxygen levels and supporting daily patterns of activity among marine organisms. These repeated motions create stability through repetition, allowing life to adjust with minimal effort. Coastal currents demonstrate how motion can remain subtle while sustaining complexity. Their influence is felt through gradual mixing, steady nourishment, and consistent renewal. Along the edges of continents, these quiet flows support ecosystems that depend not on force or speed, but on dependable movement shaped by land, sea, and time working together in calm coordination. In warm, shallow seas, coral reefs develop in close partnership with surrounding water movement. Currents pass through and around these structures with gentle persistence, shaping conditions that allow reefs to grow slowly over many generations. Though corals remain fixed in place, they depend entirely on passing water to deliver nourishment, oxygen, and microscopic food. The relationship between reef and current is quiet and continuous, built on steady exchange rather than dramatic change. As water flows across a reef, it carries plankton and dissolved nutrients that corals absorb through delicate, living surfaces. This movement also removes waste products, preventing buildup and maintaining healthy conditions. Even slight circulation can support these processes, as reefs are adapted to make use of consistent, low-energy flow. Over time, this interaction allows coral colonies to expand, layer by layer, forming complex structures that shelter countless other organisms. Currents also help regulate temperature around reefs. In periods of warming, cooler water from nearby depths or open ocean areas may pass over shallow reefs, reducing thermal stress. While this influence is subtle, it can contribute to long-term resilience when conditions remain within stable ranges. The timing and direction of water movement often determine which reef areas remain most productive over extended periods. Many reef-dwelling species rely on currents during reproduction. Eggs and larvae are released into moving water, which carries them beyond the reef before gradually returning some to suitable habitats. This circulation supports genetic exchange between distant reef systems, linking separate structures into broader ecological networks. Reef environments illustrate how stationary life can thrive within a moving world. Without traveling or changing position, corals remain connected to surrounding regions through constant water flow. In this calm partnership, currents provide what reefs cannot create on their own. Together, they form ecosystems defined by patience, balance, and the steady passage of water shaping life without haste. In the colder regions of the planet, ocean currents move through waters shaped by ice, low temperatures, and long seasonal cycles of light and darkness. Polar currents form where surface water cools, becomes denser, and begins to sink, initiating slow movement away from the poles. These currents do not dominate the ocean through strength, but through persistence, gradually influencing global circulation over extended periods of time. Cold currents carry chilled water toward lower latitudes, often along the eastern edges of ocean basins. As they travel, they help moderate temperatures in nearby coastal regions, creating cooler and more stable marine environments. The presence of these currents supports ecosystems adapted to lower temperatures, where growth occurs steadily rather than rapidly. In these waters, life is shaped by efficiency and conservation, responding to limited resources with careful balance. Marine organisms in polar and subpolar regions are closely adapted to current-driven conditions. Plankton blooms emerge during brief periods of sunlight, supported by nutrient-rich water brought to the surface through circulation and mixing. These blooms form the foundation of food systems that sustain fish, seabirds, and large mammals such as seals and whales. Each stage of growth follows the rhythm of seasonal currents, unfolding at a measured pace. Sea ice also interacts with polar currents, influencing how water moves and exchanges heat. As ice forms, salt is released into surrounding water, increasing density and encouraging sinking motion. This process contributes to deep circulation patterns that extend far beyond polar regions. Though slow, these movements play a significant role in maintaining oxygen levels and nutrient balance throughout the ocean. Polar currents demonstrate how cold environments remain connected to the rest of the marine system. Through gradual movement and steady exchange, these waters influence distant regions without direct contact. In the quiet flow beneath ice and open sea alike, polar currents sustain life through continuity, shaping ecosystems that endure through patience, resilience, and long-term balance. Oxygen moves through the ocean in quiet partnership with circulating water. At the surface, waves and gentle mixing allow oxygen from the air to dissolve into seawater. This oxygen-rich water then becomes part of larger current systems, traveling horizontally and vertically through the marine environment. Over time, these movements distribute oxygen far beyond the surface, supporting life in regions where direct contact with the atmosphere never occurs. As surface water cools or becomes denser, it may sink and carry dissolved oxygen into deeper layers. This process unfolds gradually, creating a slow but reliable supply for organisms living far below sunlight. Deep currents transport this oxygen across long distances, renewing habitats that would otherwise become depleted. The pace is unhurried, yet the effect is enduring, maintaining conditions that allow deep-sea life to persist. Marine organisms rely on this steady oxygen delivery to regulate basic processes. Fish, invertebrates, and microorganisms absorb oxygen directly from surrounding water, adjusting their activity levels to what is available. In deeper environments, where oxygen arrives less frequently, life tends to move slowly and efficiently. These adaptations reflect long familiarity with calm, limited supply rather than sudden change. Oxygen levels also influence how nutrients cycle through the ocean. In well-oxygenated waters, organic material breaks down gradually, releasing nutrients back into circulation. In lower oxygen regions, this process slows, altering how energy moves through food webs. Currents help balance these conditions by mixing waters of different oxygen content, preventing extreme separation between regions. Over extended periods, the transport of oxygen by currents contributes to overall ocean stability. It links surface productivity with deep habitats, ensuring that no layer remains entirely isolated. Though unseen, this movement supports countless forms of life through consistency rather than intensity. By observing how oxygen travels with the water, the ocean reveals another example of quiet cooperation. Through steady circulation, a simple element is shared across vast depths, allowing marine ecosystems to function in balance, guided by patience and the gentle motion of the sea. Across the ocean, nutrients move in slow cycles guided by currents and the steady exchange between surface and depth. Elements such as nitrogen, phosphorus, and carbon travel quietly within seawater, shifting locations without sudden change. These nutrients originate from many sources, including the breakdown of organic matter, river input, and deep ocean storage. Currents gather, transport, and redistribute them, forming long, continuous loops of renewal. At the surface, nutrients support the growth of microscopic plants that use sunlight to produce energy. When these organisms complete their life cycle, their remains sink gently toward deeper layers, carrying stored nutrients with them. This downward movement forms a slow transfer of energy and material from the surface to the depths. Over time, deep currents spread these nutrients across wide regions of the ocean floor. Eventually, circulation and upwelling return some of this stored material back toward sunlit waters. This return is gradual and uneven, shaped by geography, wind patterns, and water density. Where it occurs, nutrients re-enter surface ecosystems and support new growth. This process creates a continuous cycle that does not rely on excess or scarcity, but on balance and steady exchange. Marine life adapts to these rhythms with quiet precision. Organisms time their growth, reproduction, and feeding to match the availability of nutrients carried by moving water. Even in nutrient-poor regions, life persists through efficiency and long-term stability rather than abundance. The system remains productive because it is consistent, not because it is intense. Nutrient cycling reveals how the ocean functions as a single connected body. Nothing remains isolated for long. Material moves slowly between layers and regions, linking distant ecosystems through shared circulation. In this patient process, the ocean sustains itself through continuity, allowing life to unfold within a stable framework shaped by currents, time, and gentle motion working together in calm cooperation. In many regions of the ocean, layers of water remain gently separated by differences in temperature and density. This arrangement, known as stratification, develops as warmer, lighter water rests above cooler, heavier layers. Currents move through and around these layers, shaping how easily water mixes between surface and depth. The structure remains stable for long periods, changing gradually with seasons and climate patterns. Stratification influences how nutrients and energy travel through the marine environment. When layers remain distinct, surface waters may receive limited input from deeper, nutrient-rich zones. In these conditions, marine life adapts by growing slowly and efficiently, relying on recycling within the upper layers. Where stratification weakens, currents can encourage gentle mixing, allowing nutrients to rise and support increased biological activity. Marine organisms are closely attuned to these layered conditions. Plankton communities adjust their position in the water column, remaining within zones that balance light availability and nutrient access. Fish and invertebrates occupy preferred depths, where temperature and oxygen levels remain stable. This vertical arrangement reduces competition and allows diverse species to share the same area without conflict. Seasonal changes often alter stratification patterns. In cooler months, surface waters may cool and sink, allowing deeper layers to mix upward. This process unfolds slowly, refreshing surface ecosystems without disruption. In warmer periods, stratification strengthens again, restoring layered structure. Currents guide these transitions, maintaining continuity rather than sudden shifts. Stratified waters demonstrate how separation can support stability. By maintaining gentle boundaries between layers, the ocean allows different processes to occur simultaneously. Surface growth, deep storage, and gradual exchange coexist within a balanced system. Through careful observation, it becomes clear that even limited mixing plays an important role. In the calm structure of layered water, marine life finds order, predictability, and a steady environment shaped by patience and slow-moving currents. The ocean floor, though hidden from view, plays an important role in shaping how currents move and how marine life is distributed. Mountains, ridges, plains, and trenches form a varied landscape beneath the water, guiding deep currents along specific paths. As water encounters these features, it adjusts its direction and speed, flowing around obstacles and settling into channels that remain stable over long periods of time. Deep currents traveling along the seafloor carry oxygen, nutrients, and dissolved minerals into remote regions. These slow-moving flows support ecosystems that exist far from sunlight, where life depends on material descending from above or arriving through circulation. Many deep-sea organisms live close to the bottom, adapted to consistent conditions shaped by steady current movement and unchanging terrain. Seafloor topography also influences areas where water rises toward the surface. When currents encounter underwater ridges or continental slopes, they may be guided upward, contributing to localized mixing and nutrient delivery. These regions often support diverse communities, even at great depth, as the movement of water brings resources that would otherwise remain distant. Life on the ocean floor unfolds at a measured pace. Organisms grow slowly, reproduce infrequently, and rely on predictable conditions rather than rapid change. Currents help maintain this stability by renewing oxygen and carrying organic material across the bottom. In return, the seafloor shapes how those currents move, creating a quiet partnership between landscape and circulation. By observing the relationship between currents and the ocean floor, a deeper understanding of marine balance emerges. Even in darkness and stillness, motion persists. Water follows contours carved over millions of years, sustaining ecosystems that reflect patience and endurance. In these deep environments, the ocean reveals how movement and structure work together, supporting life through calm continuity and long-standing connection. Over long periods of time, ocean currents respond gently to gradual changes in the Earth's climate. Shifts in temperature, rainfall, ice cover, and wind patterns influence how water moves, altering circulation without immediate disruption. These adjustments unfold slowly, often taking decades or centuries to become clearly visible. Marine life experiences these changes not as sudden events, but as extended transitions woven into daily conditions. As surface waters warm or cool, their density changes, influencing whether they remain near the top or sink into deeper layers. This affects how currents transport heat and nutrients across the ocean. In some regions, warmer conditions may strengthen stratification, while in others, cooling encourages mixing. Currents adapt by adjusting their depth, direction, and speed in small increments that preserve overall balance. Marine organisms respond through equally gradual adaptation. Species shift their preferred habitats, moving slightly poleward or deeper to remain within familiar temperature ranges. Plankton communities adjust their seasonal cycles, while migratory animals modify routes to follow changing current patterns. These responses occur over generations, allowing ecosystems to remain functional even as conditions evolve. Currents also influence how carbon moves through the ocean, affecting long-term climate regulation. As water circulates, it absorbs carbon dioxide from the atmosphere and carries it into deeper layers, where it may remain stored for extended periods. This slow transfer helps moderate atmospheric composition, linking ocean movement with global climate processes in a steady, ongoing exchange. The interaction between currents, climate, and marine life reflects resilience built on continuity rather than resistance. The ocean does not resist change, it accommodates it through gradual adjustment. In this measured response, currents maintain connection between past and present conditions, allowing life to persist through patience, flexibility, and quiet alignment with an ever-changing environment. The ocean's currents and the life they support form a system defined by continuity, balance, and time. From the surface to the deepest layers, water moves in steady patterns that connect distant places without haste. These movements do not seek an endpoint. They persist, carrying warmth, nutrients, oxygen, and living organisms through a cycle that renews itself quietly and without interruption. Marine life exists within this motion, shaped by it rather than separated from it. Some organisms drift, some swim, and others remain anchored in place, yet all depend on circulating water to sustain their needs. Food, energy, and suitable conditions arrive not through sudden change, but through reliable passage. Over generations, species adapt to these rhythms, aligning growth, movement, and rest with the slow pulse of the sea. Currents also link different layers of the ocean into a single, living whole. What begins near the surface may eventually reach the depths, and what rests in darkness may one day return to light. This connection allows ecosystems to remain resilient, sharing resources across space and time. Even regions that appear isolated are part of a broader circulation, quietly supported by water that has traveled far before arriving. Observation of these processes reveals an ocean guided by patience. Change occurs, but it unfolds gradually, allowing life to adjust and continue. Stability is maintained not by stillness, but by motion that remains gentle and consistent. In this way, the ocean demonstrates how movement can create calm rather than disruption. As the water continues its steady paths, the relationship between currents and marine life endures. It is a relationship built on cooperation, shaped by natural forces working together over long spans of time. Within this calm circulation, the ocean remains a place of balance, offering a quiet reminder that lasting systems are often sustained through slow, thoughtful motion and enduring connection.